This is a question about vectors, so we're asked to find the resultant of a plus b. A and b are given to us here with their magnitudes. And so now for us the question is, how do we add two vectors? Well, we just have to put them end to end, right? So if we want to start with a, with b we have here, then we could just add a to it, something like this. So this would be a as well, and then our resultant would just be from the start all the way over there, something like that. But let's write this a little nicer here, over here. So we'll say maybe this is A, or keep on mixing the two. This would be B, and then we add A right there. Right, so it means I have also A over here in my force parallelogram. And B, this was A, and then I have my resultant force going from there to there. That would be R. Now, what do we know else? We know that we have an angle here. This is our angle theta. So let's say we know that theta is equal to 27 degrees. That's given to us. We also know that this angle here has to be 180 degrees minus theta, right? That's just based on the geometry of our parallelogram. And then, of course, if we have this angle and we have the two magnitudes of our vectors here, then we can use the law of cosines to find the resultant, right? So we can write R is then equal to square root of a squared plus b squared. Now in our regular one, we'd say minus ab times cosine, but we have 180 minus theta, so we can say plus a times b times cosine theta, right? Again, remember that cosine of 180 degrees minus theta is equal to minus cosine of theta, right? That's what we did right there. All right, let's plug these numbers in. See if we can fit it, right? That was A was 5 Newton. B was 3.2 Newton squared plus 5 Newton times 3.2 Newton times cosine 27 degrees. Sneak that in there. And then if we plug in the numbers, we get 7.98 Newton. If we look at our inputs, they all have two significant digits, so that will be 8.0 newtons. That would be our resultant. Now let's have a quick look at units, right? We have all of these are Newton squared. Take a square root of that and we wind up with newtons again. So that's good. So that was R, the magnitude of R at least. And now let's get the direction, right? So we want the direction from down here. It says from the reference, so that would be this angle. Now in our parallelogram, we can calculate this angle. Let's call this alpha. Right, so we can calculate this angle by using the law of sines, right? So it would be A over sine alpha and R over 180 minus theta. So we write that out. Then we can say A over sine alpha would be the same as R over sine of 180 degrees minus theta. If we solve all that for alpha, which is what we want to find, then we can say that would be sine minus 1, and then so we brought this one over, so we need to be putting R over to the other side, so A over R times sine of 180 degrees minus theta. Plug in the numbers. Sine minus 1, A 5 Newton, R 7.98 Newton. Remember to just use whatever's left in your calculator to avoid errors due to rounding. And then sine of 180 degrees minus theta was 27 degrees. And that gives us an angle of 16.5 degrees. Now this is not our answer yet, right? Because we still need to take into account this part right here, right? So let's say our overall angle would be beta, would then be alpha plus 14 degrees. So that'd be 16.5 degrees plus 14 degrees would be 30.5 degrees. That would be beta. So with that, we found the magnitude and the direction of our resultant based on the two vectors A and B.